All right, so we move on to our second mini lesson for today, and that is how do you or how is GeoGebra able to help you to do operations on functions? So remember that your functions can be operated onto. You can add functions, you can subtract functions from each other, you can multiply functions, you can divide functions, and you can additionally compose functions. So that's f of g of x or g of f of x, etc. All right. So how is GeoGebra able to help us with that? Again, let's go to making it to a split screen. To the left, it's your GeoGebra, and then your board work on the right. So they're operating on functions. So are we able to do that in GeoGebra? We'll see. We'll see. So, for example, we have two functions f and h. Let's just define them. Okay, write them as is in GeoGebra. So x cubed plus 3x squared plus 2x. Okay, so there is your first function. F of x is x cubed plus 3x squared plus 2x. And then your second function, h of x, which is x plus 2 divided by x plus 1 there. Okay, so you have on your GeoGebra screen now, you are seeing two functions. The gray function is x cubed plus 3x squared plus 2x, and the red function is x plus 2 all over x plus 1. And you are asked by this exercise the sum of the two functions, the difference of the two functions, and the product and the quotient of the two functions. So are we able to do that? Let's see. Okay, for now, let me mute these two. And I say mute the two functions. That means I don't want to see them on my screen. So all I have to do is just untick this, and you will see that your graphing screen is already clear. Okay, the two functions are still there, okay, on the console or the input bar, but okay, they are not. Their graphs are not shown on screen. It's just to make it easier for us, uh, less cluttered screen. Right. So what is the sum of these two functions? Let's see. Uh, Very simple. You just have to write it as is. H plus f. Okay. You don't need to write of x. Okay, because it's understood. GeoGebra understands that h is a function and f is a function, and you are adding. And so you will see there the graph of h of x plus f of x, and the expression as well. Like earlier, we have said that uh, the the limitation of GeoGebra for now is that it is not able to simplify this expression. So you will see that this is written in a very rudimentary way, and you have to, if you wish, you can simplify this on your own on your paper. The thing, however, that I'd like you to notice about this is that it gives you, because the graph is there, it gives you um, a very clear picture about the function, and it will be able to point to you the domain, the range of this function. You will see that this function has a domain of all R except -1. Okay. You will notice that if we evaluate this function at -1, okay, if we evaluate this at -1, you will see there the symbol infinity. Okay, so in other words, it is not in the -1 is not in the domain of h plus f. Uh, But what you will be able to see, however, is that this sum of functions h plus f has a range, okay, has a range somewhere between 0 to 2. Okay, we are not very sure what that is. Let's zoom this in. All right, so we have a range. We can do tracing. Okay, we can put a point on an object here. Okay, and then let's do the tracing. All right, kung saan yung... Okay, I guess we're looking at somewhere point what negative 1.88. So that means that the range of this function, okay, the range of this function is between positive 0.06 to, let's put another point on the object here, okay, and you'll see here, yun na ba yung lowest? Okay, about 1.94, about 1.94. So 0.06 and 1.94, okay, this function does not have any y value within this interval 0.06 to 1.94. But beyond that, so below 0.06, this function has a y value which is below 0.06, and this function also has a y value above 1.94. Okay, so again, you're able to get these the from the trace of the new function h plus f. Okay, let's mute again h plus f. Sir, how about h minus f? Okay, very easy again. So you just do h minus f, and you will get this function. Okay, let's zoom that out because I think this is a pretty interesting. Right, so this is the trace of the function. All right, so this is now h minus f of x. Again, the limitation of GeoGebra for now is that it cannot do simplification for you. So you will see here an expression in its raw form, and you will have to, with your paper and pencil, simplify this. Okay, um, let me just inspect if that is true. If I were to look at the algebra, okay, there's no, right, there's no, okay, indeed. Sir, what will be the domain of this function? Again, this function will be defined over all r except at -1. You will see again that at -1 it is asymptotic. Okay, so if you want, you can show that. Okay, see, so this function just gets closer and closer to x equals -1, but never quite at x equals -1. Right, so what is the range? However, this function has quite a good range. Okay, it can take the y values of this function can take basically all r. Okay, so you can have y values from -infinity going to 0 and y values from 0 going to positive infinity. Okay, right. So how about, sir, the product of the two functions? So the same with as earlier, just write hf, or if you want, you can write hf there. Okay, so you have your product of two functions, h times f of x. Uh, let's check. Okay, this is the thing with GeoGebra now. It cannot show you hollow points. You will expect that this function h times f of x should be hollow at -1. This must not have any value at -1 because the moment you substitute -1 on x, then you will have a denominator which is 0. So what you do is you evaluate this at -1. Okay, is there a q of -1? Question. Ah, and GeoGebra gives you back a question mark. Okay, which means that okay, nagma-math error siya. Okay, so it is encountering some math error. That's why it gives you back a question mark. Okay, because you know that if you graph this on your paper, this should be hollow at x equals -1. Okay, so this function is defined, the product of the two functions h and f is defined over all r except at -1. Except at -1. The range of h times f of x is also, it is also all r. So all, it can take all values, all possible values of y, which is real. Okay, because from -infinity, you can see that y can be from -infinity going to 0 and going from 0 up to +infinity. So it can take on any y value as long as it is real. Okay, so lastly, can we get f over h? So f divided by h of x. Yes, okay, it can also get uh, f over h of x. You will see, however, that again, it cannot show you hollow points. F over h of x must show you two hollow points. You cannot have x equals -1 and additionally x equals -2. Let's check. Is there an r of -1? Oh, okay, it has 0 now. Okay, I guess what GeoGebra did here was to, at the back end, okay, it's not able to show it, but GeoGebra did simplification. It put x plus 1 on the numerator together with x cubed plus 3x squared plus 2x and left x plus 2 as the denominator. And that is why when you substitute x with -1, you will get 0. Okay, but you know, you should know that domain-wise, x equals -1 should already be excluded because you cannot have, rather your h of x cannot have a value at x equals -1. Now, let's check the other point at x equals -2. What is r of -2? Again, you will see GeoGebra gives you back a question mark, which means it is encountering some mathematical error, which is correct because when you put x plus 2 now here, your denominator will become 0 because -2 plus 2 is 0 over -2 plus 1, which is -1. That gives you 0. So the denominator for the expression f over h becomes 0, and therefore you cannot have a value there. Okay, so again, this quotient of two functions f over h has two restrictions. X cannot be -1 and x cannot be -2. Although you will see that your GeoGebra is also limited in that respect because it shows you that the function must have a value at x equals -1, which should not be the case. It should not be the case. All right, so we have shown that GeoGebra can show you the behavior of functions as you operate them using your arithmetic operations of addition, subtraction, multiplication, and division. The question is, can it show you composition of function? The answer is yes, it will be able to show you. Let's see that in a minute. All right. So you have two functions here. Let me define again the two functions here first. So you have f of x is equal to the quotient of x plus 1 divided by x minus 1. That you have there. And you have g of x, which is the quotient of x minus 3 and divided by, kailangan niya ng parenthetics, all over x plus 3. Right. So you will see here the two functions. Let me zoom that out. Okay, just for us to be able to see, the purple function is x plus 1 over x minus 1, or f of x. And the gray function is x minus 3 over x plus 3, or g of x. And then you're going to ask, so can you get the composition of these two functions? So let's mute these two first. Can you get g circle f of x? Okay, well, g circle f is just g of f of x. So we'll write g of f of x. Okay, so this is now g circle f of x. You will see here again that GeoGebra is not able to show you a simplified expression for g circle f. Okay, that will have to be left to you to do as exercise on paper and pencil. However, what it is able to show us neatly, okay, is that the graph of the composite function g of f of x. And more than that, okay, you are more inclined actually to check what is g circle f of 3. So what is g of f of 3? Okay, which you are able to see naman. It is at negative 0.2. If you want to see this on the function, then you just have to write 3g of f of 3. All right, and there you will see that GeoGebra can graph it for you, nicely. All right, so there is 3g of f of 3. Okay, you might want to know as well what is the domain of g of f of x. Okay, so firstly, you will notice already here that there will be an x that this is asymptotic to. Okay, and our job is to find out what that is. I think it is 1/3. Let's see, x is equal to 1/3. Ah, no, it's not 1/3. All right. I think the domain for this will be best seen if we see a simplified expression for h of x. Unfortunately, we cannot do that right now because domain h. Okay, domain h. GeoGebra is not able to do that for us as of the moment. Okay, so maybe in the future, as developers, as GeoGebra developers, continue to make this better, they will be able to. All right. So I guess finding the domain of G circle f of x will have to be left with the procedures that is left to you in your learning guides. Okay. So finally, we want to find out what is f circle g of 0. So, sir, what is f of g of x? Again, GeoGebra can give you GeoGebra can give you f circle g of x. Let's mute this first. F of g of x. Okay, so you will see here that f of g of x is simply a line. Okay. F of g of x is simply a line, right? Does this have a value at... Okay, you want to find out what is f circle g of 0, so you just have to f of g of 0. All right, and you will be able to see that f of g of 0 is 0. Let's check that mentally. What is g of 0? G of 0 is negative 3 over 3, which is negative 1. So f of negative 1 is indeed 0 kasi negative 1 plus 1, 0 over negative 1 minus 1, which is negative 2. So 0 over negative 2 is indeed 0. All right, so and you'll be able to see that the trace of f circle g or f of g of x is a line. Okay, so there, GeoGebra can indeed help you doing operations of functions. It can help you sum functions, subtract functions, multiply functions, divide functions, and compose functions. However, the finding of the domain, that I'm afraid I will have to leave that to you still using paper and pencil and the procedures given to you in your learning guides because GeoGebra still has limitations on these two questions. Okay. Um, After this will be the third mini session for you.